So as you can see here, there's quite a bit of wobble left to right, and now that could well be because I didn't have all my bolts all tightened up, but either way, it's just far from satisfactory. It needs to be far tighter than that. What it does is connect from the left-hand side of rail, up through the pivot arm and across the other side, then back on the other side of rail. So it goes through a lot of mechanisms and a few joints in order to go and connect the left side slider to the right side slider. So I went, okay, need to go and make this a little bit more sturdy. So then got into Fusion 360 here and added in this plate. And normally this would have created me a great deal of angst because cutting that out of aluminium, drilling all the holes where they're supposed to be, make it all fit, that's just not my thing. But I just go and extract it out, that particular plate out, and then just things like milling slots in there rather than holes, because I figured, hey, I might need a little bit of leeway in order to go and make things align. But in the end, it was all pretty sweet. Unfortunately, this time I forgot to go and add in some registration pins for the milling job. Normally I'd make that all one job so I could put the piece wherever I want, and it'll put the registration holes where they need to go. I'll put the pins in, drop the aluminium in there, right in its place, and off it mills fine. But this time, it's because I didn't put the pins in, it meant that I had to try and align the metal up with the CNC router itself and get its axes all right. So therefore, it was all aligned, and that was just in pain. I'll never do that again. I'll just put pins in, make it drill its holes, and away we go. Forget trying to align the job to the machine. Too hard. And then here's installed. See, there it is. This is a work of art. As you can see, it propelled me well into the 22nd century. It does its job well. Everything is nice and robust. So move it side to side, and not really much happens. So yeah, it's just hard to move. Hard to hold a phone and wobble it backwards and forwards, but it does its job well. Right. So here's my test run. It's on a very low powered power supply. It's like 24 volts, current limited to 5 amps. So I was able to get 100 watts out of it. Really, that's a 360 watt motor. So it's quite under spec. But it's still, if I took it easy, it did the job. And as you can see, it's quite brutal. Yeah, I'm sure that I can go and lose a finger quite easily with this. It scares me a bit, actually. So it does cut. Just have to go very, very slowly. Of course, the safety stick is in place. Keeps little fleshy bits away from the blade. Of course, nothing's stopping the blade from self-destructing or something like that and just flying off at me, but all getting jammed like that. Very easy to get jammed because that blade has very little kerf on it, if that's a term. So therefore it tends to bind up quite easily. But I'm sure that with extra grunt, it'll do its job. And then just to prove that it does cut nicely, you can see, did some aluminium and timber, it cut through it, albeit slowly, but it was very accurate. At right angles, perpendicular, everything it should be. I was really happy with the result. I could not cut that neatly and accurately if I tried. No way. So, it does the job that it's supposed to do. And that's the end of the video. And once again, I'd like to thank my subscriber, because as the saying goes, if a YouTube video is published and there is no subscriber to view it, do I even exist? Catch you on the flip side.